Hello and namaste everyone, it's me Sanjeet Thapa Magar. Welcome to my channel Engineer Star. Today I will be discuss the numerical of design of tension member of the subject design of steel and timber structure. Uh, I will solve the past questions of Purvanchal University. So tension member, uh, the member which is subjected to axial force, that is pull, is called, or tension, pull or tension is called tension member. In tension member the problem is of usually three types. First will be the angle section. This may be equal angle or unequal angle, but there is only single angle, and here is rivet or bolt. In second case, there is two angle section connected back to back like this, and here is also rivet or bolt. This is the second case, and in third case, the angle is connected in both sides of gusset plate. This is a third case. So all this case will be covered in this numerical. First question that was asked in 2019 Purvanchal University is design a tension member of steel angle section to carry an axial tensile load of 120 kN. Use power driven field rivets at end connection and draw the sketch. Angle, we need to use this angle section to carry an axial load. So this is the first case. In first case, there is a gusset plate, and here is only one angle, and in this WSM working stress method we use rivet to connect this plate with gusset plate. This is gusset plate, and this is this angle section, and this is rivet. So tensile load is 120 kN, which is given in question. Permissible stress in axial tension is 150 megapascal, that is 0.6 times 250 This is given in clause 4.1.1.1 of IS 800 1984. 4.1, here it is given that the permissible stress in axial tension sigma AT. A means axial, T means tension, in megapascal on the net effective area of the section shall not exceed. This should be less than this 0.6 times Fi. Fi, if in question not given, then Fi is 250 megapascal. So 0.6 into 250 is 150 megapascal. 150 megapascal. Area required. From school we have learned that stress is equal to force divided by area. So rearranging, area is equal to force denoted by P and stress denoted by sigma, but in tension member you use AT, axial tension. Choosing an angle section having a section area about 20% more than A net. This is A net, 800 mm square, about 20% more than the A net. That is about 20% more is 800 into to convert mm square to centimeter square, we divide by 100, so it will be 8 centimeter square. So this 20% more, that is 8 into 1.2 is 9.6. So the area should be greater than 9.6. Angle section. So from here it is angle section, so area more than 9.6. This is the area column more than 9.6. We can choose this ISA 6060, ISA 755010. We can choose this also, but I have choose ISA 755010. I have choose unequal section, so in unequal angle column table, 755010. 755010 is, where is area? This is area, so 11.52. By increasing 20% we get 9.6. So more than 9.6 is this. We can also choose this section, that is 704510, which is also greater than 9.6, but I choose this. You can choose any, so I choose ISA 7550 and the thickness is 10. 7550 10 and the area is 11.52. Since the diameter is not given in question, so we can use this formula 6 root T. Some book there is 6.01, in some book 6.05. It varies, so you can take approximate 6 root 2, which is easier to remember. 6.01 root 10 is around 19, and 6 root 10 is 18.97, that is 19 meter. So diameter, this 19 millimeter diameter rebate is generally not available in market, so this we have to choose a rebate of higher diameter than this, which is 20. So gross diameter of rebate is 20 plus 1.5. 20 is the diameter of rebate, but diameter of hole of plate, gusset plate or angle section is denoted by D, which is 1.5 meter more in this case. If the nominal diameter is less than or equal to 25, according to this clause, if the diameter is less than, this is nominal diameter is less than or equal to 25, we add 1.5, and if the nominal diameter is greater than 25, we add 2. So this 20 is less than or equal to 25, so we add 1.5. So 20 plus 1.5 is 21.5 millimeter. Here, the diameter of rebate hole shall be taken as nominal diameter phi plus diameter of hole is 5 plus 1.5 mm for rebates of nominal diameter less than or equal to 25, and plus 2 for rebates of nominal diameter exceeding 25 is, that is greater than 25 unless otherwise specified. So this less than 25, so we choose this 1.5, and the net effective area is denoted by A net, which is A1 plus A2 times K. It is given in clause 4.2.1.1. 4.2.1.1 this. In the case of single angle connected through one leg on the net effective section, this is a gusset plate and single angle. This is angle section, single angle connected through one leg. This is one leg. Then the formula will be this A1 plus K2A, and the K will be calculated as 3A1 divided by 3A1 plus A2. 3A1 divided by 3A1 plus A2. Now, what is A1? This is gusset plate, and this is one angle, and the A1 means the area of the side leg which is connected to gusset plate. This is gusset plate, and A2 is the side which is not connected to gusset plate. This is A2 and this is A1. So we do the rebating in here. So to calculate A1, this from here, this is A1 and this is A2. So 75 is from here to here, it is 75 minus 21.5 is this diameter and 10 by 2. The thickness is this is the thickness, which is 10, so 10 by 2, 10 by 2, because this is 10 and this is also 10. 10 divided by 2 will make this area like this. If we do not reduce this, then it will be like this, and A2 will be this. So this will be taken twice. So to reduce, half will be reduced from this and half will be reduced from this. So and multiply by thickness. This from here to from this middle, it is this, and multiply by thickness is this. Similarly for this, from here to middle is 50. This 50 minus 10 by 2 is from here to here, it is 50, and from here to here it is 50 minus 5, that is 45. So it will be 450 and it will be 485. And 3 into A1 is 485, A1 is also 485, and A2 is 450. So K is equal to K1 is equal to 0.763. So A net is equal to A1 plus K1 A2. A1 is 485, A2 is 450, and K is 0.763. Strength of member. This formula I have already shown. Stress is equal to force divided by area. So strength is maximum force that can be resisted without failure. It's equal to sigma A. So strength means that capacity, the maximum force which can be withstand by the member safely. So sigma is sigma A2, sigma axial tension, and A is A net. Sigma AT is 150 and A net is 8 to 8.35, which is 124.25, and the load acting in this system is 120 kilonewton. This system can withstand a force up to 124, but only 120 acts in the this connection, so it is safe. Okay. And in connection, in sharing, the formula of this is force is sigma into area, and sigma in this case in sharing is tau BF, and area is pi d square upon 4. That is the area of hole. This area, so this is the area which resists the shear force. This is the diameter of hole, it resists the shear force, so pi d square by 4 into tau BF. So it will be 32.674 kN. And in bearing, the bearing is resisted by this. In another view, it is like this is the rivet, and here is gusset plate here and angle section in here. So the tension force will be like this, and in bearing means if the load acts in this direction, the rivet will try to move. This angle section will try to go in this direction, but this will resist. So it is bearing strain is this stress times area. Area is this diameter time this thickness is in this. So this diameter times this thickness will resist this bearing. So bearing strain will be dt tau pf, which is d is diameter of hole, that is 21.5, thickness is 10, and sigma pf is 270, and this will be 58.05 kN. So we have to use power driven field rivet. In page number 95, power driven rivet is this, but there is field rivet. For field rivet, the permissible stress shall be reduced by 10%. That means in shear it is 100, and 10% of 100 is 10. So we have to reduce 10%. So 100 minus 10 is 90, and here it is 300, and 10% of 300 is 30. So we have to reduce 10%. So 300 minus 30 is 270. 90 and 270. And 270. Rivet value is the minimum of this two, that is 32.674. If we take this value, then it may fail on shearing, because it can only withstand up to 32.6 shear force. So we must choose the minimum value. Number of rivet, the total force acting on the system is 120, and rivet value is 32. So 120 by 32 is 3.67. So we cannot provide 3.67 rivets. So either we have to choose 3 rivet or 4 rivet. If we choose 3 rivet, then this may tear, or this may fail by shearing, or if we choose this, it is not safe. So for safety, we choose higher. We should always round up, not round down, round up to 4. So pitch distance is minimum pitch distance is 2.5 times nominal diameter. If the force is acting in this direction, then pitch is the direction parallel to the force, and this is the center to center direction between two consecutive rivets. This is the P. So minimum pitch is as given in question in code 2.5 times nominal diameter was 20. So 2.5 times 20 is 50 is the minimum value. So we can take pitch as 60 millimeter, and S distance this is given in 8.10.1 8.10.1. The distance between center of rivets should not be less than, that is, should be greater than 2.5 times of nominal diameter. In this case, nominal diameter is 20. So 2.5 times of 20, and S distance for 21.5 mm hole. For 21.5 mm hole, S distance is we can take 32. If it is hand flame cottage, 32. So we can take slightly greater than 32, that is 40. So this is the figure. This is a gusset plate, and this is ISA 75 by 50 by 10, and this is 4 number of rivets of 20 mm diameter rivets. This question was asked in 2017. Design a tension member 3 meter long. Member, the length is 3 meter. Using two angle section, we need to use two angle section to carry 250. Axial load P is 250 kN. Angles are connected on both sides of gusset plate. If this is the gusset plate, this is the one side and this is one side. So angles are connected in both sides of gusset plate. So this is the required figure. By 16 mm diameter, the diameter of rivet is 16 mm. And it is hand driven. It is driven by hand. So permissible stress in axial tension is 0.6 Fy, 0.6 to 50, that is 150 megapascal. Area is axial load divided by sigma AT. Axial load is 250 in kilonewton. To convert in Newton, we multiply it by 1000, and sigma AT is 150. So this is 1666.667 mm square. To convert it in centimeter square, we divide by 100. So area is 16.667 centimeter square for both angle, and for one angle area is, for one this angle section area is, this divided by 2 is 8.333 centimeter square. So our area should be, the area of one angle section should be greater than 8.333. You can choose up to around 30% extra, so that you can perform less trial. In exam there is no time for multiple trials, so which increase up to around 30% of this area. So I have chosen I say 75 75 10. 75 75 is equal, so this is on equal, this is equal 75 75 10. 75 75 10 and area is 14.02. You can also choose this. You can also choose this. They all are greater than 8.333. So I choose 14.02 because in exam we don't have time to do multiple trial and error. So I choose 14.02. So R minimum for this is 1.45. R minimum for 75 75 10. R minimum is minimum from this, so minimum is 1.45. 1.45. So this is the figure. This is 75 and this is also 75 and this is also 75 because it is equal angle, and this is the rebate here, and this is a gusset plate. This is a third type of numerical. So in this type of numerical, A net will be gross area minus deduction of wall. So gross area of one section is 14.02. For two section it is multiplied by 2. 14.02 is centimeter square. To convert centimeter square into millimeter square, we multiplied by 100, that is 10 square minus deduction of hole. The diameter, hole diameter is I think 17.5 for 16. It is 16 is less than 25, so plus 1.5, that is 17.5 into 10 plus 10. So this is 17.5 and for this it is 17.5 into 10, and for this the area of hole is this is 17.5. No, this is 17.5 and this is 10. So diameter of both, area of both hole is 17.5 into 10 plus 17.5 into 10. 17.5 will be common, so it is 10 plus 10. If the thickness of one plate is 8 or 12, then we can change accordingly. So A net will be 2454 millimeter square. Safe load is sigma into A. because stress is force divided by area, so load is sigma into A. Sigma AT is 150 and sigma A net is 2454 with this 838. This can resist the load up to 368 kN, but the load is only 260, so it is very safe. If we have choose on if we have chosen this section or this section, then there is also okay, that will be also economical, but may not be safe. So check for cylinder ratio. In question, the length is given as 3 meter, that is 300 centimeter, and 3000 millimeter. So effective length lambda is slenderness ratio is L by R min. This is 3000 by R minimum is 1.45 is in 1.45 is in centimeter. To convert it in millimeter, we multiply it by 10, so it is 206, which is less than 350, so it is safe. So this value is also given in code. In table 3.1, and the maximum slenderness ratio is this given in page number 30. So our case is a member normally acting as a tie. So what is the question? Tension member. So a member normally acting on a tie is tension member in a roof truss or bracing system, subject to possible reversal of stress. Tie is a member subjected to tension force, but it may be subjected to possible reversal of stress from the action of wind or earthquake force. If wind or earthquake force occurs, then it should also resist compression. So for this, maximum slenderness ratio lambda is 350. So slenderness ratio should be maximum 350, but it's only 306, so it is okay. And in connection, this is hand driven rivet, and page number 95. Hand driven rivet, tau is 80 and sigma is 250. Tau B of is 80 and sigma P of is 250. Strength of rivet in double shearing. So the area that will resist shear force is in this type of two angle connected in both sides of gusset plate. The area that will resist is this area and this area. This area is pi d square by 4, and this area is also pi d square by 4. So 2 pi d square by 4, and this tau is shear stress is tau bf. So tau bf is 80, so it will be 38484.5 Newton. Strength of rivet in bearing is again this diameter and this thickness will reduce the bearing, and the thickness is minimum of both, since it is both is 10 millimeter, so thickness is 10. So strength of rivet is in bearing is 250 into 17.5 into 10. Rivet value is minimum is 1 2 3 4 5 1 2 3 4 5. Minimum is this 38484.5 Newton. Number of rivet is force divided by rivet value. Force is 250 Newton kilonewton. To convert it in Newton, we multiply by 1000, and rivet value is this, so 6.52. So we must round up for the safe. That is 7 rivet we should provide. So 1 2 3 4 5 6 7. The diameter is, I think, diameter is 16 mm. So 7 rivet of 16 mm diameter, and minimum pitch is 2.5 D. We can take, in code it is nominal diameter, but we can take gross diameter as well for safety. That is 43.75, so we increase to 45 millimeter, and minimum is distance is 2D, that is 2 into 17.5, that is 35 mm. This is pitch is 45 and S distance is 35 mm. This was another question asked in 2017. Design a 2-meter long tension member. So length is 2 meter, subjected to a pull of 220 kilonewton. Pull, that is tensile load, that is 220 kilonewton. To convert kilonewton into newton, we multiply by 1000 or 10 power 3 and place back to back. Back to back means this is gusset plate and two unequal angle, so one leg is not equal to another leg, so two unequal angle placed back to back with the shorter leg connected on same side. That means unequal angle means this is shorter side and this is longer side, and this shorter side is connected to gusset plate. This is gusset plate, so shortest side is connected to gusset plate and longer side is hanging. Shorter side is connected to gusset plate and longer side is hanging. So this is 18 mm die rivet. Use hand driven rivet as joint. So area required is force divided by sigma 80. Force is 220 into 10 power 3 and sigma 80 is 150 for axial tension, and A required is 1466.67 millimeter square. To convert it in centimeter square, we divide by 100, that is 14.67. so this is area required for two angle. For one angle it is 14.67 divided 2, it is 7.33 centimeter square. Let us try this. So we have to choose angle section greater, unequal angle section greater than 7.33. This is angle, so we need to choose equal, no unequal. So area was 7.33, so we need to choose greater than 7.33 centimeter square, greater than 7.33. We can choose this also, or this, or this, this. I have chosen 8056. 8056. I have chosen this 7.46 centimeter square. 7.46, and our mean is for this 7056. Our minimum is 7056 is 6 is the second. So R is given in this 4 column, so minimum R is 1.07. From this 4, minimum is 1.07. So area is 50 is the shorter length connected in gusset plate. This is 50, and from here to here is 80. So for this 2, because we have used 2 angle, and 50 from here to here, it is 50 minus 19.5 is this diameter, and 6.2, because from half will be deduct from here and half will be deduct from here, so half of 6, and 6 is the thickness. And in A2 is the standing not connected lead, that is this is 80, and 6 by 2 into 6, that is 924 millimeter square. K1 is for this case. It is given in cloths. Tension member. $47. In case of pair of angle back to back or single T connected by one leg on each angle or the flange of T to the same side of gusset plate, the net effective area is A1 plus A2K. A1 plus A2K, and K is 5A1 divided by 5A1 plus A2. 5A1 divided by 5A1 plus A2, it is 0.641, and A1 is 330, K is 0.641, and A2 is 924, so it is 922. And required area is for both angle, required area is 1466, but it is only 922, so we have to redesign. So choose 7550 by 8, which has the area of 9.38. This has area of 7.46, so we have to increase area to around 9. This is heat and trial method, so around 9.38. that is 7558. 7558, that is 9.38. 9.38, and R mean is this is the second last row of 7550. 7550, second last row is this, and the minimum R is from this 4, minimum R is 1.06. 1.06. So we can proceed similarly. Instead of this 6, we have written this 8. So A effective is 1163, but A required was 1466, but it is only 1163. So again we have to redesign to 9068, slightly greater than this 9.38, that is 11.37, that is 9068. 9068, it is 14.01. No, it is 8, so 11.37. 11.37, and R which is around 11.4. so R mean is second row of 9060. Second row of 9060, that is this. Minimum R value is 1.28. 1.28. So by similar process we get A effective 1519, but required was 1466, but the effective area is 1519, so it is safe. So I have done these 3 trials. So this is trial 1, this is trial 2, and by choosing this section it is trial 3. So in exam, if you don't have more time, then you can directly choose this value, because A required was around 7.33, so we can increase directly to 30%. 7.33 into 1.3 is 9.5, so it is less than 9.5, so we skip this, and it is also less than 9.5, so we skip this, and it is greater than 9.5, that is the area is 30% more than this area required. So you can directly start in exam with this this section to reduce the number of trial. So A1 is 2 because 2 section, and A2 is 2 times shorter leg length was 60 and longer leg length was this, and diameter of hole was this, and this is the thickness. So by this formula we get this. So safe load is A50 times sigma 80, 1519 times 150, that is 227890. To convert it in kilonewton, we divide by 1000, so it is 227.89 kilonewton, and the force acting was 220. Force acting was 220, but it can resist up to 227. So okay, cylinder ratio is L by R minimum. L is 2 meter, so 200 centimeter divided by R minimum is in centimeter, 1.28 centimeter, so it is 156.25, which is less than 350. So okay, so we have to provide ISA 9060 by 8 millimeter section for hand driven rivet, because use hand driven rivet. So for hand driven rivet, tau value is 80 and sigma value is 250. Tau BF is 80 and sigma BF is 250. Strength of rivet is pi by 4 into d square into 80. To convert it in kilonewton, we divide by 1000. Bearing strength is this, 250 is this, sigma PF, and thickness is 8 and diameter is 19.5, and divide by 1000 to convert it in kilonewton. So minimum of this is 23, which is rivet value. Load is 220 kilonewton and rivet value is 23.89 kilonewton, so it is 9.2. so rounding up to 10, we provide 10 rivets. Pitch distance is minimum pitch distance is 2.5 times nominal diameter, so we can choose pitch as 3D. 3 into 19.5 is 58.5, so we choose 60 millimeter, and S distance is 2D. 2 into 19.5, that is 39, so 40 is preferred. So 40 is the S distance, and this pitch is 60, and this is a gusset plate. This is ISA 9068, and the rivet is 10. So here 1 2 3 4 5, and here 1 2 3 4 5 10. In another view, this length of both section is 90, and this shorter side length is 60. And this is the question like 2017, but in 2017 connected shorter leg connected on the same side of gusset plate. Here is shorter side, but in this question we use longer leg connected on same side of gusset plate by 18 mm diameter rivet. Diameter rivet, and length is 2 and force is 220, and driven 220 and driven. This is the same question, but only the difference is this: longer leg connected in same side of gusset plate. So area required is as usual P by sigma 80. P is 220. So to convert it in Newton, multiplied by 1000 divided by sigma 80 is 150. So it is 14.67 centimeter square. This is the area of these two unequal angle. For one unequal angle, it is the divided by 2, it is 7.333 centimeter square. So we choose 75, 50, 10 because it is unequal, so this should not be equal to this. 75, 50, 10 unequal. This is unequal, this is also unequal, this is also unequal, this is equal, so in unequal we choose 75, 50, 10. 75, 50, 10 area is 11.52. So it is greater than 7, so okay. We should select the section by choosing the section area greater than this, and we have to increase up to 30% to reduce the number of trials. So by increasing this 7.33 up to 30%, it is around 9.5, but I choose 11.52, which is okay. Slightly uneconomical, but it is safe. So diameter is 18 given in question. Diameter whole is 1.5 because this 18 is less than 25, so 1.5. So 18 plus 1.5 is 19.5. Net area is 2 times A1 plus key A2 because there is 2 angles. So longer side connected in gusset plate. So this will be the connected leg, and this is unconnected length. Connected length is longer, which is longer is greater of these two, so this is 75, and diameter is 19.5, and thickness is 10. Similarly, here is no rivet, so we do not reduce the diameter hole. So by this formula, key is this, so by putting the value of A1, A2 and key in this formula, A net is 1773.2. so required area was 1466, but provided area is 1773, which is safe, which is greater than A net, so safe. Okay, since length is given, we must calculate slenderness ratio. R mean for this case 1.4 is this. It is the minimum of this value. You can also choose this. So it is greater than 150, so okay. Design of in connection. For hand driven rivet, tau T of is hand driven rivet tau is 80 and bearing is 250. Tau B of is 80, sigma B of is 250, and this sigma in tension is 0.6 into 250. Sigma T of is also 80. Sigma T of should be 80 megapascal. So strain in of rebate in shearing is area is pi d square by 4 and stress is tau bf, so pi into 19.5 square by 4 and this is 80, so divide by 1000 to convert it in kilonewton. Bearing stress is sigma bf dt. Sigma bf is 250 and diameter 19.5 and thickness 10, divided by 1000, this is 48.75 kilonewton. So rebate value is minimum of these two, that is 23.89 kilonewton. Minimum pitch is 2.5 times the nominal diameter, 2.5 times of 18, that is 2.5 of 18 is 45. And for tension member, maximum pitch is 16T or 200, whichever is less. 16 into T is 10, that is 160 or 200, and the minimum is 160. This is written in this code. So minimum pitch is 2.5 times of nominal diameter, and for maximum pitch it is 16T or 200, whichever is less in tensor member. We are dealing with tensor member now, so 16T or 200 mm, whichever is less. 16T or 200 mm, whichever is less, and less is 160 mm. So minimum is 45 and maximum is 160, so we can choose this 50, which is between these two. Number of rebate is load is 220 and rebate value is 23.89, so 9.2. So rounding up we get 10 rebate. So in one row we can use 5 rebate. So in this 1 2 3 4 5 and in this 1 2 3 4 5, and the pitch is 50. Pitch is center to center distance of rebate in the direction of force, so pitch is 50 50 50 50, and edge distance for the 19.5 mm hole is 32. If in case of hand flame cut edge is 32, so we can increase up to 40 mm, that is 4 centimeter. So this and this is gusset plate, and the diameter of rebate is 18, and edge distance is 40. This is 2, here is 1 and here 1, 2 ISC 75 50 10, and from here to here it is 15, and from here to here also 75, here to here also 75. So in question, longer leg is connected in gusset plate, so longer leg is 75, which is greater than 50, connected in gusset plate. So this is the question that was asked in 2016 of Purvanchal University. A tie member 2.5 meter long, length is 2.5 meter, carries an axial load is 210 kilonewton. Design a suitable double unequal angle. Unequal angle means one leg is not equal to another leg, and we must use hand driven rebate. And the area net is 210 into 1000 force in Newton divided by area in mega, stress in megapascal, that is sigma 80, which value is 150, so it will come 1400 millimeter square, and area required for each section is 400. 1400 divided by 2, that is 700 millimeter square, and to convert in centimeter square we divide by 100, that is, so area required for each section is 7 centimeter square.